Hi everyone, I hope you're having a great night tonight. This lecture that I'm doing is going to be about 30 to 45 minutes. It's going to cover a small part at the beginning of our Unit 2. Unit 2 covers life, chemistry, and water. It's going to give you the fundamental chemistry that's going to allow you to understand how reactions work regarding the reactions in biological systems. So that's what we're going to do. At the end of this, there's going to be a few questions for you to answer. If you go into your D2L, you'll find those. And we'll go ahead and get started here. So for this lecture, we're going to cover the first part of this, which essentially is atoms, and then we're going to talk a little bit about chemical bonds. We're not going to get into it extremely deeply because that's what we're going to start in class, but I want to give you just some introduction into it. So let's talk about atoms. Now, in order to understand what atoms really are, we need to go a little bit more into the fundamentals of chemistry, which is talking a little bit about matter. And matter is pretty much anything that occupies space and has mass. Now, most everybody knows what it means when I say occupy space, but it's the question that what is mass actually? So let's talk about that a little bit. Now, mass is just the measurement of how much material is in an object. Our mass never changes. Now, on Earth, mass and weight, basically we use it the same, but mass and weight are different. Weight has to do with gravity and the pull of gravity on us. Now, our mass essentially remains the same. For instance, here, if we're looking at this sweet little girl here, her mass is 56 grams. And that mass is going to be the same whether she's on the moon or on Earth. What changes is the weight. And the weight changes because of the pull of gravity. Of course, gravity is less on the moon than the Earth. So essentially, her weight is less on the moon. Now, how do we go and actually classify matter? Well, we have two ways. You can look at it as just a mixture, or pure substances. And we're going to get into both of these when we talk a little bit more. When we talk about mixture, we're either talking homogeneous has to do with the same, or heterogeneous has to do with different things being mixed together. Now, when we talk about pure substances, we can talk about either compounds or elements. And essentially, in both of these, we're going to discuss them in more detail in a moment. So, of course, pure substances are one type of atom or one type of molecule coming together, where mixtures are going to be where we start to physically combine things. So let's first hit on elements, and then we'll get into things a little bit more complex here in a moment. An element is just something that it's a substance that cannot be broken down into other substances by basically normal chemical means, right? And so all matter is composed of chemical elements here. And how we essentially arrange elements is here on the periodic table. So if you look in here, basically, these guys over here, these are what we're going to basically be dealing with most of the time, and these are what are called nonmetals. Everything else, these guys here are metalloids. You can see down here, right? Nonmetals is this area that is yellow. Semi-metals, also known as metalloids, are these areas. They kind of have properties of both. And then if you go from this point on, all of these things over here, except for him, he's a nonmetal. That's hydrogen. But all of these in this area are going to be metals. Now, these blue guys over here, these guys are what are known as noble gases. And as we get through this lecture, you'll find out that essentially noble gases, just like nobility, it doesn't like to combine with commoners. It kind of likes to be off to itself. It's because these guys are really stable. And by the end of this lecture, you're going to understand why they're stable. Now, these alkaline metals over here, these guys are the most reactive on this periodic table. For instance, if you look at here, potassium by itself is a really cool reaction when you mix it with water. It basically explodes to a certain point. So we're going to kind of go into what these actually mean. For instance, you can see they're arranged. Here's 1, 2's here, and then you can see they're in increasing order. And that's going to mean something important here. And if you look on here, you'll notice that every single one of these elements, none of them have the same number. That's because this number is telling us how many protons are in every single one of these elements. And that's the number of protons tells us what element we have. So matter can be found on Earth in 4 physical states. Of course, you have solids, which if you look here, oops, sorry about that. Let me go back. Oops. Here we go. If you look on here, solids, if you'll notice, solids are going to, in general, are the heaviest of the 3 physical states. And that's because generally the atoms in matter are the closest together. Liquid is going to be the next, and if you see, they get, they'll be a little bit farther together than solids. Solids are very, very structured. Liquid is not. Gases, the atoms are the farthest apart. They tend to be the lightest. And plasma, it's something we're not really going to talk about in this class because it has to deal with the composition of stars. And these are just gases that are charged, right? So for the most part in this class, we deal with solids, liquids, and gas. Now within those different physical states, each one of them is composed of elements, and elements' basic unit essentially are atoms. And atoms are the smallest unit that retain the chemical and physical property of an element. And basically what happens is if we want to form molecules, we do this by combining atoms together. So if you see an atom, like the example here, is just helium, and that's helium by itself. So atoms are just going to be single elements. Now if they actually come and they react together, you can get molecules. And you'll see this is a molecule of what we call oxygen or pure air, right? And you can see here you actually have 2 atoms of oxygen coming together to make a molecule. Now this guy right here, if you see, this is water, it's H2O. And here, this guy is considered both a molecule and a compound. So molecules are these things that are just a combination of atoms, right? They can be the same or different atoms. It's just meaning that they're reacting. So you can see that this guy right here, oxygen, it has 2 atoms of oxygen, but they're interacting with each other. And this guy here, water, has 3 different atoms coming together, oxygen interacting with hydrogens. So if the atoms that are combining are different, then they're called compounds. So with this in mind, right, all compounds are molecules. You write this in here, all compounds are molecules. But not all molecules, or not all molecules are compounds. So at this point, I'm going to give you a few minutes. I'm going to actually stop this recording, let you think about this. And what I'm going to ask you is take these following entities. This is what's known as methane. This is hydrogen gas. Actually, CH4, sorry. And I want you to determine which is a molecule, which is a compound. And I'll be back in the next lecture.